Hello grade 9 students. Welcome to another virtual class. I am Miss Madhu Vadke. We are studying chapter 12 Heron's formula. In today's video lesson we are going to revise the concepts that we have studied and solve some questions of higher difficulty level. Let's recall the concepts and the formulas of this chapter. Consider triangle ABC in which we know one side of the triangle. Let's say we know base BC. And we also know the corresponding altitude to this base. Now altitude is a line that is drawn from a vertex perpendicular to the opposite side. So AD is the altitude corresponding to the base BC. Let's mark this base as B1 and the height corresponding to this base as H1. So the area of this triangle ABC will be given by half base into corresponding height. So half B1 into H1. If we take AC as the base, B2, then the corresponding altitude will be drawn from B perpendicular to AC. Let's mark this base as H2. So the area of same triangle can be given by half B2 into H2. And if we draw perpendicular from vertex C to AB and mark this height as H3 and the corresponding base as B3, then the area of same triangle will be given by half B3 into H3. Also, we can use the same formula to find the height of the triangle. Height is equal to 2 times area divided by the corresponding base. So if I want to find H1, then I will have to divide 2 times area by B1. If I want to find H2, then I will have to divide 2 times area by B2 and so on. Now let's say we have an obtuse angle triangle ABC. If I take BC as the base, then can you draw the altitude for this base? We know that altitude is a line drawn from the vertex perpendicular to the opposite side. Now in an obtuse angle triangle, one of the angles is greater than 90. So here angle ABC is greater than 90 degrees. And the angle between the altitude and the base is 90 degrees. This implies that altitude from A cannot be inside the triangle. So in this case, to drop an altitude from A onto BC, we will have to extend the side BC. And then we will drop a perpendicular from A to the extended side BC. So now AD is perpendicular to BC and the area of this triangle ABC will be equal to half base into height, that is half into BC into AD. This is something that you should already be knowing. Since this is a revision class, I am just going over the concepts. What about other perpendiculars of this triangle? If I drop a perpendicular from point B, will it lie inside? Yes. What if I drop a perpendicular from C? Will it lie inside? No. To drop a perpendicular from C to the opposite side AB, you will have to extend AB and then drop the way we have done over here. I hope this is clear. Now in the chapter we also studied that in a right angle triangle, the side opposite to the 90-degree angle is hypotenuse, and that is the longest side. The other two sides are perpendicular to each other. So if we take one of them as the base, then the other one becomes the height. And we can find out the area of this triangle by multiplying these two sides with half. And if we take this side as the base, then the other perpendicular side becomes the height. But if I want to take hypotenuse as the base, then the corresponding height will be drawn from the opposite vertex to the hypotenuse. We also studied how to find the area of an equilateral triangle. If each side of the equilateral triangle is A, then its area is given by √3 upon 4 times side square, that is A square. You can also find the altitude of an equilateral triangle using the formula h is equal to 2 times A upon the base. So 2 times √3 upon 4 into side square divided by the base, which is also A. So when you calculate this is √3 upon 2 times A. We studied a new formula in this chapter which is called as Heron's formula, which is used when all three sides of a triangle are given. So in this case, to find out the area, we find the semi-perimeter, which is denoted by S, that is the sum of all three sides divided by 2. Then the area of this triangle is given by root of S into S minus A into S minus B into S minus C. So let's solve some questions now in order to test our skills. Question number 1. The perimeter of an isosceles triangle is 42 centimeters and its base is 3 on 2 times each of the equal sides. In an isosceles triangle, two sides are equal and the third unequal side is called as the base. We are given that the perimeter is 42 centimeters. Let's mark the equal sides as x. So using the information given in the question, base is 3 upon 2 times each of the equal sides. We can write base equal to 3 upon 2 times x. So the perimeter of the triangle will be AB plus AC plus BC equal to 42 centimeters. So that is x plus 3 upon 2x equal to 42. On adding, we will get 2x plus 3 upon 2x equal to 42. This is same as 7x divided by 2 equal to 42. So x is equal to 42 into 2 divided by 7. So that is 12 centimeters. So let's say side A and B of the triangle are equal to 12 centimeters and the base of the triangle is the third side, which is 3 upon 2x. So 3 upon 2 into 12 is 18 centimeters. So now we have all three sides, so we can find out the area. Semi-perimeter is P upon 2. That will be 42 upon 2, that is equal to 21 centimeters. Therefore, area of this triangle is square root of S into S minus A into S minus B into S minus C. That is square root of 21 into 21 minus 12 into 21 minus 12 into 21 minus 18. That is square root of 21 into 9 into 9 into 3. Splitting 21 as 3 into 7. We get identical factors of 3 and 9. So we can write them out of the square root. 7 is single, so it will be written under the square root sign. So this is same as 27 root 7 centimeters square. According to this question, we have to find the height of the triangle. So in this case, the base is already given as BC. So we have to find the height corresponding to this base, which is 18 centimeters. Therefore, using the formula, height will be 2 times area divided by the corresponding base. So 2 times 27 into root 7 divided by 18 will be dividing by 9. So 9 to the 18, 9 3s are 27. 2 and 2 cancel, so we get 3 root 7 centimeters as the height of the triangle. Second question, find the area of the shaded region in the figure. Look at the figure. The shaded region is part of triangle ABC, which is obtained if we subtract triangle ADB from it. So to get the area of shaded region, we will subtract the area of smaller triangle from the area of bigger triangle. Now notice that the smaller triangle is a right angle triangle in which the perpendicular sides are given, so we can find its area using half base into height. Observe the bigger triangle. We have only 2 sides. We can find the third side from the information given for triangle ABD. Since this is a right angle triangle, we can use Pythagoras theorem and find AB, which is hypotenuse and opposite to the 90-degree angle. Triangle ABD is right angled triangle. Therefore, we can use Pythagoras theorem. So square of the hypotenuse, that is AB square, is equal to BD square plus AD square. Substituting the values of BD and AD, we get 12 square plus 16 square, which is 144 plus 256. On adding, we will get 400. So AB will be square root of 400, which is equal to 20 centimeters. So now we have the third side of triangle ABC. So we can find the area of triangle ABC using Heron's formula. Let's find the area of each of these triangles. So area of triangle ABD will be equal to half base into height. Now if I take the base as 12, then the height will be 16. So this is equal to 96 centimeter square. Let's find the area of triangle ABC. For that, we will first have to find the semi-perimeter, that will be A plus B plus C divided by 2. On adding the sides, we get 120 divided by 2, which is equal to 60 centimeters. So the area of this triangle ABC is equal to square root of S into S minus A into S minus B into S minus C, that is equal to square root of 60 into 60 minus 20 into 60 minus 52 into 60 minus 48. This is equal to 60 into 40 into 8 into 12. Now factorize each of these numbers to find pairs of identical factors. 60 can be written as 6 into 10. 40 can be written as 4 into 10. And 8 we will write as 4 into 2. 12 will be written as 4 into 3. Now writing pairs of identical factors, 6 into, I will write this 2 into 3 as 6, then 10 into 10 is another pair, 4 into 4 is another pair, and this 4 I will write as 2 into 2. So now I can write down the square root for each of these pairs. So we get 6 into 10 into 4 into 2. So the product of these numbers is 480 centimeters square. So we get area of triangle ABC equal to 480 centimeters square. So therefore area of shaded region will be equal to area of triangle ABC minus area of triangle ABD. That is 480 minus 96, that is equal to 384 centimeters square. With this we come to the end of this video lesson. Here is a mind map of the concepts that are there in this chapter. This part of the chapter is deleted from the portion. Now this is not a very comprehensive mind map. We have learnt more concepts than what are written over here. So your assignment for today is to make your own mind map for this chapter. See you in the next class. Until then, goodbye.